What is the difference quotient? In this example, we're asked to find the limit of what we call the difference quotient. More on this in a second. To solve this limit using the same way we've been doing, we would go ahead and try direct substitution, plugging in the 0. That would end up giving us 0 over 0 in indeterminate form. So what I'll do is I'll go ahead and simplify the numerator. That comes out to be h squared minus 10h. Knowing that dividing by 0 is a problem, and therefore this factor h in the denominator is a problem, I factor the numerator and I cancel out the h terms. This leaves us with the limit of h minus 10 as h approaches 0. Plugging in 0, we get negative 10. Great, so we found that this limit is equal to negative 10, but that still didn't answer the question of what is the difference quotient? The difference quotient, which is represented by this expression f of x plus h minus f of x over x plus h minus x, represents the average rate of change of a function over some interval. Note that this looks a lot like y2 minus y1 over x2 minus x1. If we were to clean up the denominator here, x minus x would cancel out, you would just be left with h. This looks a lot like the original expression we started with. In our case, our function was just x squared, and the x value we were plugging in was negative 5. By taking the limit of our difference quotient as h approached 0, we were actually able to find the instantaneous rate of change, or the slope, at x equals negative 5. Graphically, that means looking at our function, we would go to the point x equals negative 5, and at that particular point, we could find a tangent line here that has a slope of negative 10. So that's what we mean when we talk about the difference quotient.